kids, we're going to look at the quiz we just took today, or maybe you're watching this tomorrow, which would make the quiz you took yesterday, or just whenever. We're going to take that quiz and we're going to do it together with you right here, right now, and get all your questions about these pesky vectors answered.
Indeed.
Okay, so let's start off with number 1. Feel free to skip around if you felt like you got number 1 just fine. Skip to what you need to know, but here we go.
Okay, let's dive in. So you've got a vector, you've got a point. P is the 0.13, Q is the 0.310. Find the component form and magnitude.
And specifically for PQ.
From P to Q,
yeah,
yes.
Because that matters, actually.
Start and stop is pretty important on this.
To find PQ, we need to do the second point minus the first. So for our x values, that's 3 minus 1.
Right.
For our y values, that's 10 minus 3.
Right.
So that's what?
4 and 7.
Are you sure?
Pretty sure.
2 and 7.
That's what I said.
That's the component form. Component form is where we have an x and a y component.
And you got the thingies, not the parentheses.
Yeah, we got angle-y bracket thingies. And now let's find the magnitude, which is...
I know exactly what to do.
Okay.
Square the 2.
Okay.
Square the 7.
Okay.
Add them together.
Okay.
Take the square root.
Okay. And what we're doing there is basically the Pythagorean Theorem, because every single vector we have, we could draw as a triangle.
What?
Where we have an x and a y, right? So these are sides. So we're just finding what C is in the Pythagorean Theorem.
The distance, how long the vector is.
Yeah, how long is it?
It's that long.
4 plus 49 is square root of 53, and you can leave it like that.
If you write a decimal answer,
that's silly.
That's just crazy
You're
business.
Just being silly.
Yeah.
Okay.
Okay, all right. So
now find the component form of the indicated vector. They give us u and v, and they want us to find negative 3u plus 5v.
And so those are scalars, which means that the negative 3 multiplies with all the numbers inside the component form of the vector, and the 5 multiplies with all the numbers inside the component form of the vector.
Right. We could write it like this, where I just stuck u and v in, and then look,
just distribute.
It's a distributed. Yeah.
Hey, how long you been distributing?
So long I can't even remember when I started.
I mean, there you go. I mean, so we're going back to keeping it simple.
Yeah. Now, what about you? Was that before or after paper was invented?
I actually learned to distribute right before paper was invented. I just got retweeted.
Congrats. That's the dream, to be retweeted. Okay, so I distributed the negative 3 into u and the 5 into v, and now I can add the vectors
let's add
together.
First part goes with first part, second part goes with second part.
3 plus 25 is 28.
Yep.
9 plus 25 is
34.
That's all it asks us for is the component form. So that right
Bingo,
there.
bango, bongo.
Yep. Okay, so
chitty, chitty, bang, bang.
Unit vectors.
Okay, now think about what we just said. Say it again.
I don't know what you're talking about.
Say it again.
Unit vectors.
Think about what, okay, so you just say it one more time.
Unit vector.
A unit vector is a vector that is exactly one unit long.
Right.
It is a unit vector.
Right. You could not be more right. Now, we've got this formula that's on, I put some formulas on my whiteboard that we need to make sure that your kid...
We'll talk.
Yeah. Okay, so we've got this formula, and one thing that can throw you off here is that this u is not this u. This is the v in this formula is the vector they're giving us that we're changing.
They're giving us
the
vector 1, 5.
Okay, so we need to find the magnitude of 1, 5 and put it down here on the bottom, and then we're multiplying it by 1, 5.
Right.
So the magnitude is
1 squared plus 5 squared.
Right.
And that's going to be the square root of 26.
Right.
And
so,
don't we're good. We're good right there.
Square
root of 26. Bueno.
Yeah, no decimal. 1 over square root of 26. We're multiplying that into 1, 5 because we're trying to find a unit vector. So our answer better be a vector. You just distribute this in, and there's nothing to cancel out.
Right. So this vector right here that we're writing down, this vector is exactly 1 unit long.
And we could check if we wanted by squaring this
do
plus
the Pythagorean
Theorem,
theorem,
and then add them together and square root, and you get 1.
Right, there you go. Oh, it wants it in I and J form.
Oh, no.
Oh,
let me take back that box.
Wow, no, you're good. That's component form right here.
Right,
now,
but that's not the
No, but that's okay. So I and J is a really simple just really simple, quick fix here. We just take 1 over root 26 and put an I behind it, plus 5 over root 26 and put a J behind it.
Right.
And that wasn't hard.
No. This is a different way of writing the component form.
Yeah, that's all there is to it.
J's.
Right.
So that's 1 through 3.
There you go.
All right, number 4, find the component form of the vector v. Here's vector v. Here is, what would you call this? Would you call this like an angle, maybe theta?
I would call it an angle maybe alpha.
Too bad we're calling it.
Oh, shoot.
11 is our magnitude because it's telling us the length of this line, which goes with our magnitude. So that's the magnitude of v. There is a formula for that.
I know what it is. Before we write it down, I know what it is without looking.
Okay.
Magnitude v cosine alpha, comma, magnitude v cosine alpha, sine alpha, end comma.
Yeah,
if I was writing,
totally,
those would be alphas.
Totally. Okay, so we plug these in to this formula.
Right. Yeah. Good job.
And
Good job. Yep.
then
Oh, dang it. I'm not going to get that level of Candy Crush.
that's too bad. That's really too bad. We plug this into our calculator. Make sure your calculator is in degree mode. And it gives us as our answer
I don't have my
negative
calculator.
8.426, comma 7.071.
Sure hope you plugged that in correctly.
Okay, now when you look at this, you might be thinking, okay, do we use 140 or do we use some other angle? Because we did a whole bunch of stuff with like bearings
Right,
and all of
which
that.
way are we going?
So it's understandable that you might have looked at this and been like, well, should maybe I have put 40 in here? Well, you shouldn't, because what's going to happen is for the component form, it's giving us the correct signs
Right.
if we use 140.
Right.
So if you had tried 40 instead,
You would have been in the first quadrant.
right, so you'd have to either put in the negatives yourself, or you'd have to realize, okay, that's not what I was supposed
Yeah.
to do.
When you're doing trig, this is how you do it. When you're
Right.
doing bearing, is the only time that we have the goofy
Have to
axis.
switch around
Yeah.
and do stuff like that. Okay, so we want to find the magnitude and direction for the following vector. Give the direction angle as an angle in the interval from 0 degrees to 360 degrees, rounded to the nearest tenth.
Woo.
Now, what we tend
Okay,
to
magnitude.
forget,
Okay, we can do magnitude though. That's easy.
Yeah. Well,
Okay, draw your thing.
Can I draw
Yeah,
a picture?
go ahead. Yeah, draw a
Because
picture.
This is what it seems like some people forgot. 7, -2. A vector is a line, right?
Which creates a right triangle with
Right.
the x-axis.
And so don't forget that that's the case, because we know all kinds of junk that we can do with
all
right triangles.
kinds of
all
junk.
Kinds.
Okay,
So
we're gonna
kinds-
pause. Hold on. Why? That's my Twitter feed. There we go. Okay, sketchbook. What were we talking? SOHCAHTOA, I believe. Casey was just yelling at you before we had to take a quick pause.
I'm sorry. It was my bad. Okay, so magnitude. We do have a formula for that, right? But
And
it's
we've got a right
basically-
triangle as well.
Basically, the
I mean,
Pythagorean Theorem.
Yeah, come on.
That part, I think.
49 plus 4, it's 53. Everybody knows that.
I think that part has gone pretty well. That's the magnitude of the vector. And
Find the magnitude. Done.
Okay, yes. Now let's give the direction angle.
Yes, indeed.
And so that's the angle to get from 0 around.
All the way around.
And the reason it's from 0 all the way around is because they asked us for an angle between 0 and 360.
Right.
So whenever we look at this, we could do any trig function technically we wanted to, because we know the hypotenuse.
Yes.
But just in case, like, what if we accidentally added wrong,
Oh,
right?
use
So
tangent.
Just in case,
Better use tangent just in case.
because that uses the information they
Yep.
gave us.
Arctan.
Nice save.
That's good save.
Nice
Good save. Opposite over adjacent.
Inverse tangent of -2/7 gives us -15.9 degrees. But you have to remember,
That's below. That's fine, and that's what I got right there. Yep.
and that almost actually, in this case, -15.9 degrees, that is what that angle is.
Yeah.
But it's not the angle between 0 and 360.
Nope.
So we have to do-
-15.9 is outside of that.
We have to do 360 minus 15.9, which gives us 344.1.
344.1. Does that answer make sense?
Well, it makes sense to me. 344.1 is in the fourth quadrant.
I mean, I'm just
Can't get
just
much better
asking.
than that.
Yeah. If you get an answer of like 270, that's probably not going to work.
No, probably not.
Yeah.
But that's how you find magnitude and direction.
Oh yeah.
All right, we've got an airplane that flies on a compass heading of 90 degrees. That's the same as bearings, okay, of 90 degrees. So bearings start at north and go clockwise.
Right.
So 90 degrees is right here along the positive x-axis.
Yep.
That's how our airplane is going. So it's
Remember,
going,
north is always 0 with bearing.
Right. So we are going at a magnitude of 390. That trig angle, like the one we would use for our calculator,
would be
is
0.
Okay, our normal angle, or I like to call it a trig angle, because
trig
when
angle.
we do just trig problems,
When you're having to do the actual math,
yeah, that's
you're
what
using
it is.
trig.
Okay, so now whenever we do this next part, we need to think of this. Like, I like to put this at the end here, personally, and it tells us about this, that the wind affecting the plane is blowing from 344 degrees.
Right.
344 degrees, if we stick it on the end here, is this way. Okay, where we've got 16 degrees left over here, basically.
Right, from north all the way around to 344, so
Right.
360 minus that.
Right, but if it's from this direction, then our arrow is down
It's
here
got a
at the
point,
bottom.
yeah, right.
So if we're going to add these vectors together and we want to show that, then that really needs to be right here.
Right.
Okay, and so we've got vertical angles here from trig back in the day.
I just got favorited on Twitter.
Would you stop it? 16 degrees is right there, which means that this trig angle would be 270 plus 16.
Right.
Which is 286. So the info about this one is that we are at 23 miles per hour, okay, at an angle of
For the math
286.
part. For the math part.
For the math part of it.
Right.
Okay, so what we need to do is we need to put this into vector components. So we've got the plane, and component form for that is 390 cosine 0.
Right, and then 390 sine 0.
Right.
390 being the magnitude, 0 being the trig.
Right.
Angle.
We're gonna add that to the wind.
The wind beneath my wings. Hoo-hoo.
23 cosine 286. 23 sine 286.
Yeah, Roger.
Okay, we have to find those in decimals, and then add them together.
Make sure you're working degree mode on your calculator.
Right. The first one, actually, you could have figured out without your calculator.
Yes.
It's 390 comma 0.
You need to be able to figure it out without your calculator.
Well, sure. 390 comma 0. And then the other one, if we find it on our calculator, is 6.340 comma negative 22.109. Now, take a second to see if those make sense. 390 means we're going to the right, 390 not up or down.
Right.
From there, we're going some to the right for 6.3, and then we're going down
just a little tiny bit.
so negative 22. So that makes sense. We add these vectors together to get our result. So we add our x's, which give us 396.
Good thing you did all that math.
0.340.
Can't count on me to punch it in correctly on a calculator.
That's not what's happening here. We didn't have a calculator over here, and I happened to bring the key with me where I worked it out.
That's what I'm saying.
That's all.
Good job.
Okay. This is the vector. That's the result. So that's the vector going from the start here.
That's how
to
the plane's
stop
actually
there.
flying.
Yeah, and so whenever it asks us for the true course and ground speed, it's asking us for the magnitude and the bearing for this vector.
Oh, we got to undo everything we just did.
Right. So with this resultant that we got, we need to do the Pythagorean theorem.
Ugh. Did you work that one out too?
Did you really just groan at the
went,
Pythagorean
ugh,
theorem, which is
with-
the greatest theorem?
No, but it is great.
ever?
I'm not knocking that. But look,
Ever?
396.340 squared plus negative 22.109
Why,
squared.
it's
That's
396.956 miles per hour.
Who knew that? Wow. Okay, I take back my groan about good old Pythagoras. He's a bro. We were homies back in the day when I was in high school and he was in college.
Who?
True story. Me and Pythagoras.
You guys were, wow, you are a lot older than I thought you were.
Yeah. If we're gonna make old jokes, I'm
Yeah.
gonna own up to it.
So inverse tangent of y over x is going to give us the angle, but it's going to give us the reference angle, so we
Right.
will have to do some work.
Just a little bit, but not much. Yeah, that's not a vector there.
And that gives us negative 3.193.
Right, so that means x-axis, 3.93. Right
Yeah,
there.
like our image isn't quite to scale. And if you think about it, basically the wind here is not affecting it very much.
No, not
think
really.
of
Hardly at all.
390 versus 23. It's not affecting it very much at all. So if this angle right here is 3.193 and we want the bearing, we need to do 90 plus 3.193. And that's our true course.
Right.
So that's 93.193.
There you go. That's it. That wasn't that bad.
No, not bad at all.
All right, keep going.
Dot product.
Don't mess this up.
Okay, you have to remember that these i's and j's can just...
They become
they're
components.
just-
Where the
Look at
i's and
this.
j's goes.
Look
Oh
at
no.
this.
Oh no.
Okay, don't stick them in there when you do dot product or any other sort of thing. When you do vector addition and scalar multiplication and stuff, you can leave them in there because it's like terms. But
Right.
for dot product, they don't go with it. So 5 times 3, first times first, plus second times second.
Okay, not hard.
Right here.
Look at there.
15 minus 28 is negative 13.
There you go. I could almost do that in my sleep.
Yeah, you
I
probably
could be
so.
asleep like this and
Be like-
write it out and
Yeah.
be totally right.
We have a formula
That
on
is a
number
bright
8.
green color. Wow.
That we do the dot product on top of the magnitudes multiplied together, and we inverse cosine that. Let me pick a better color.
That's really
U dot
bright.
V is first times first, negative 9 times
Negative 8. Yep. Plus
plus
1 times 7. So there you go.
Positive 72
Yep.
plus 7 is 79.
79.
The magnitude of U, do the Pythagorean Theorem on U.
So that's
on
going
you.
to... no, on you.
I'm writing here.
Oh,
What
you're
are you
writing.
doing? That was-
Shoot a monkey. Negative 9 squared plus 1 squared. That's U version 3.72, which is going to be 80... I don't know.
What?
And then the magnitude of V is going to be negative 8 squared plus 7 squared, which is 56 and 49.
I have no idea what you said earlier.
I don't
Square root
either.
of 113.
Yeah, so there you go. Square root of So
Now
there's
we
your
have
2 square roots.
all
Now,
the parts.
leave the square roots in there. Don't do anything to them yet. Just be patient, young Padawan learner.
If your calculator will do fractions, then make it do fractions and set it up exactly like what it looks like here.
Right.
If it will not give you like the fraction over a fraction, if you don't have that option, you need to put the bottom here in parentheses.
Right. On the 83s
79
and some of those
divided
numbers.
by, and put this in parentheses that's
Right.
on the bottom. And if you do that correctly and you're in degree
And
mode,
you're arc cosigning the whole time.
34.8 degrees.
34.8, baby.
There you
And
go.
ask yourself,
Does that make sense? Does that make sense? You could draw
you could draw a picture and look at it.
and it probably will make sense
If
you drew the picture to scale and stuff.
Right. Look at that.
Two
Shazam.
color.
Oh!
No, that's
Tater.
write the vector u as a sum of two orthogonal vectors, one of which is the vector projection of u onto v, and then it says projection of u onto v. Now, here they're telling us in the instructions what we're supposed to be doing in case you've forgotten how this problem works.
Yeah,
we
it's
are
possible
trying
you
to
could have.
trying to take u, the vector u. We're trying to write it as the sum of two vectors. So let's call those vectors u1 and u2. Sum means
In
addition.
the
Okay,
name of love.
can we not do that again? Like, can we not?
Do you not
Can we
like
just
my?
not?
All right.
Okay. One of these, it really doesn't matter which one, but one of them is the projection of u onto v. So you might as well make u1, since I have to say that more. Might as well make that one be the projection of u onto v. Okay. And then the other one,
What's the other one called?
I'm not saying. The other one will end up being u minus u1. Okay? So
Okay.
we need to find two things. The projection of u onto v, and then we need to subtract.
What's that other one called? I can't tell.
I don't know. I think it's called uz.
You're
Pretty
no
sure that's what
fun.
it is. Okay. The projection of u onto v is a formula. Do you know the formula?
It's got a dot product on it,
It does.
and you divide by a magnitude, and you multiply with a vector. Gosh, I'm so good.
Oh, you left something.
I forgot the squared. Dadgum. Son of a biscuit eating. No, we're good.
Okay.
Just,
Okay. Oh, yeah.
There's people in your room waiting. Like, they want you, I guess.
Oh, okay. Thank you.
They want you.
Okay. I don't know what we're going to do from here now that that happened. All right, whatever. Dot product of u and v.
The dot product.
8 times 2. First times first plus second times second.
Yep.
16 plus 24 is 40. V, the magnitude of v squared.
Squared. Okay, so all you have to do is just square each piece of v and add them up.
Right, because what
when
we're
you square
doing
square root,
is
it goes
squaring
away.
this.
Yeah, so
Squaring the square root.
Yeah, 4 plus 16, 20. I mean,
Okay, so this is our fraction, 40 over 20, that goes outside of v, so that's 2, 4. We need to distribute and simplify. Whichever order you want to do that in is fine. Like, I personally am like, oh, 2. Let's distribute 2.
I'm one of those kinds as well. It just makes life so much nicer.
So the projection of u onto v is 4, 8, which is u1. So now we need to find the second u. So to find that take what u originally is. It's 8, 6.
See how it is.
Minus what we just found, 4, 8. And that gives us, are you ready for it? Are you ready?
I know, 4, -2.
Which is u2.
In the name of love.
Okay, so we've got u1 and u2. If you wanted to check yourself, those should add up to be what we originally had for u.
It looks like it's going to be 8 and 6.
All right, number 10. If they are parallel, orthogonal, or neither. So.
Oh, this is like, don't let this one be hard.
Orthogonal means that their dot product is 0. So
There you
let's
go.
try that. 8
Let's do
times
it.
6. First times first plus second times second.
No, I'm thinking not, but maybe. But
Really?
not,
Because this
but
is 48 minus
it's
48.
plus 48, right? Plus.
I put a negative somewhere I shouldn't have. This is that's a multiplication.
That's multiply. That's
Sorry,
okay.
sorry. So 48 minus 48 is 0. It's orthogonal, and then you can stop. Some people ask me sometimes. I don't know if anyone's asked you this. Sometimes people ask me, can you have vectors that are orthogonal and parallel?
You know, I'm gonna have to go with a no.
Because orthogonal is a fancy word for perpendicular.
Perpendicular.
Can you have two angles be perpendicular? Let's pretend these are perpendicular. Can those also be parallel?
You know, maybe in a parallel
Never.
universe.
Maybe if we're doing like hyperbolic geometry instead of Euclidean.
I don't even know what you just said. But
That's okay. That's what I was going for.
okay.
Okay, so
All right.
what is the minimum force required to prevent a ball weighing 27 pounds from rolling down a ramp,
That is a heavy ball.
which is inclined 13.6 degrees with the horizontal? So we've got this
Situation.
hill ramp thing. Okay, that is inclined at 13.6 degrees.
I sense some sort of right triangle business coming.
Well, not necessarily. I just drew a right triangle.
oh, okay.
For funsies.
Okay, well, for kicks and giggles.
Yeah, the ball has a weight of 27 pounds. So there is a vector here that's pushing down on the ball.
Called gravity.
Called gravity. It's pushing down with 27 pounds. What we want to do is figure out how much of that force goes this direction along the hill, because that's how much we need going the other direction to prevent it from moving.
Okay, right.
So,
Because we want it to be stationary.
so this is a projection question. We're trying to project 27 pounds onto the hill.
Okay, do it.
So that means that we need a couple of vectors here. We need this vector for 27. We could say that's 0, negative 27 because it's a vector pointing down
With magnitude 27.
with a magnitude
I
of
like
27.
it. All right, it's a good call. It's
Okay.
a good call.
The 13.6, we can use that to find a unit vector because unit vectors are awesome,
Yeah, because if you have a unit vector, you can make it any magnitude you want to.
right?
Yeah.
Okay, and whenever we do this, this is going to end up being U for our projection formula, and this is going to be V for our projection formula. So,
Projecting away.
let's see here.
Does U2 come? Is U2 coming?
No, U2's
Oh, there's no U2?
No. If we do the dot product of U and V, and I haven't actually figured out what these are, but all we do for the dot product here is first times first plus second times second. So we really just need negative 27 times sine 13.6.
Yeah, because 0 times anything is 0. So
U dot V should be negative 6.349. Okay, if you do this in your calculator, this times this, you should get that. And then on the bottom of our projection formula is the magnitude of V squared. Well, since we use a unit vector, we know the magnitude of this is 1, and you square 1 and you still get 1. So we have negative 6.349 times our vector V.
good handwriting, K. Steve.
Thanks.
Don't stop.
So we distribute, and that's going to give us the vector right here that is this direction, and then we'll have to find the magnitude.
Okay.
So we distribute, and we get...
Punch it down on your calculator, K.
Yeah.
Steve. Punch
No,
it
I
in.
have it right here. 171. I just had to find it. You know what I mean?
I know what you mean. I know what you mean, bro.
Okay, this is the vector that is pointing down the hill. And then the magnitude of that, you would do the Pythagorean Theorem.
Gosh, look at that decimal you're squaring out. I don't know. 6.171 squared. By the way, BT dubs, make darn sure that you put the numbers that are negative inside of parentheses, because no bueno if you don't. You'll get an imaginary number.
Totes. 6.349 pounds. And then if you're thinking about whether or not this makes sense, well, because at 13.6 is really not a very big incline.
It's not very big.
Like, that's not that
kinda
hard
small.
to walk up. And so it kind of makes sense that a very small part of that 27 pounds is actually going to be the
Trying to roll down.
the
Right.
hill. So next, number 12. Next and last.
12er fever.
We have a force of 22 pounds acting in the direction of 1, 2. In moving an object 8 feet from 0, 0 to 8, 0, there's two formulas for work. You could use either one.
They both do the same thing.
They both, yeah, totally. It
Totes.
just depends on what you want to
Same
find. Because some of it's given to us and some of it we'd have to work to figure out. If we want to do the first one, that means we have the magnitude and a direction vector, but
Right.
not the actual direction. So you got to do this one of two ways. Either figure out what the direction angle of this is by using inverse
Which
tangent.
wouldn't be hard because that's just a quick tap on the calculator.
Right. Or you can find a unit vector for 1, 2. So 1 squared plus 2 squared, square root that, and we get
Square root of 5.
square root of 5.
What were you writing
I
there?
don't know.
A
And so
heartbeat?
you just divide both of these by the square root of 5. So 1 over the square root of 5, comma, 2 over the
You
square root
know,
of 5.
I love unit vectors because now we can make that any length we need
Right.
to.
You just stick a 22 in
Boom.
front of it and distribute, and now that's what F is in component form.
In component form.
And so let's not worry about decimals yet. 22 over the square root of 5, comma 44 over the square root of 5. That's F. The vector AB, well, if we're going from 0, 0 to 8, 0, that's a vector.
Ooh, I know. 8, 0.
8, 0. You almost said
I
it
almost
wrong.
said it backwards, but I didn't. I self-corrected myself.
Okay, and so we're using this formula. We're going to dot product those together. So
Dot 'em.
first times first plus second times second.
Second one's going to be 0.
The second one's going to be 0. We're doing basically 22 over the square root of 5 times 8, which gives us... Do you know?
No,
Do you know
not
what
off
it
the top
is?
of my head.
Do you know? Do you know off the top of your head?
No.
Do you know off the top of your head?
I know off the top of my head it is
78.71
78.710 foot-pounds.
foot-pounds.
Yeah, that's totally what I got.
Yeah, so there you go. There you
All
have
right.
it.
There you go. There you have it. Signing off.
That's the way the cookie crumbles.
That's the way the
Just hold your
apple
horses.
falls. That's the way the trig goes.
That's the way we inverse tangent to find the angle.
Boom, that's a good one.
Thanks.